You killed an animal. It is lying in front of you. A massive carcass. Shoulders higher than your head. Legs thicker than your torso. 500 pounds of meat, bone, fat, and fur. Your own body weighs maybe 130 pounds soaking wet. You have no truck, no wheel, no horse, no ox. No, just your legs, your back, and maybe a few other people who are just as tired as you. How do you move this thing even 10 feet, let alone 10 miles back to camp? This is not a hypothetical. This was a problem your ancestors solved thousands of times across hundreds of thousands of years. Every successful hunt ended with the same impossible question. How do you transport an animal that outweighs you 4-to-1, sometimes 10-to-1, across rough terrain, with no mechanical advantage, before predators show up to steal your kill? You think hunting is the hard part? Hunting is the easy part. Getting the meat home is where the real test began. Let me start with a modern assumption. When you think about ancient hunters, you probably imagine a group of men dragging a whole animal carcass back to camp. Maybe they tied ropes to its legs and pulled. Maybe they carried it on their shoulders. This image is so embedded in our imagination that it appears in museum dioramas, textbook illustrations, and every caveman cartoon ever made. It is almost certainly wrong. In 1968, archaeologist Perkins and his colleague Daly published a paper on a Neolithic site in Turkey called Tufanatolv. They noticed something strange. The bones found at the settlement did not match the expected composition of a whole animal skeleton. Certain bones were overrepresented. Others were almost entirely absent. Perkins and Daly coined a term for what they were seeing. They called it the Schlepp effect. The Schlepp effect is simple. When a hunter kills a large animal far from camp, they do not drag the whole thing home. They butcher it at the kill site. They cut away the heaviest, least useful parts and leave them behind. They carry only the most valuable pieces. This seems obvious once you say it. But this changes everything. A modern elk weighs about 700 pounds. Its edible meat is roughly 300 pounds. Its bones weigh another 100 pounds. The hide, organs, and antlers add more. If you try to drag 700 pounds of dead elk across 5 miles of savanna, you are going to fail. You are going to exhaust yourself. You are going to attract every predator within a 10-mile radius. And you are going to arrive back at camp with an animal that is already starting to spoil. So you do not drag the whole elk. You leave the heavy bones behind. You slice away the meat in manageable strips. You carry the choice cuts. The Schlepp effect means that the farther a kill is from camp, the less of the animal gets transported. Hunters make cost-benefit calculations with every pound of meat. Is this leg worth carrying 5 miles? Is this rib cage worth the energy it takes to haul it? The answer is almost always no. In 1986, Henry T. Bunn and Ellen M. Kroll at the University of Wisconsin published a landmark study of the F.K. Zinjanthropus site at Olduvai Gorge in Tanzania. This site, discovered by Mary Leakey in 1959, is one of the most famous archaeological excavations in history. It dates to roughly 1.8 million years ago, and it contains clear evidence of what Bunn and Kroll called systematic butchery. The bones at FLK Zin showed cut marks, not random scrape marks from carnivore teeth, but precise, deliberate incisions made by stone tools. The cut marks clustered on the parts of the skeleton that carried the most meat, the upper limbs, the pelvis, the shoulder blades. The parts that were hardest to carry whole were precisely the parts that had been cut away. Bunn and Kroll argued that this was not a kill site. Animals were not dying at this spot. This was a home base, a central camp where early hominids brought meat to share. They had killed animals elsewhere, butchered them, carried the meat back to this spot, and continued processing it there. The butchery marks were evidence of transport. They were the archaeological signature of the Schlepp effect in action. Let that sink in. 1.8 million years ago, your ancestors were making cost-benefit calculations about meat transport. They were deciding which body parts were worth carrying and which were not. They were solving logistics problems that modern supply chain managers would recognize. Now consider a more recent study. In 2015, Dr. Brianna Pabina at the Smithsonian Institution published experimental research on bone transport. Pabina and her team took animal carcasses, butchered them with stone tools, and documented which bones got transported and which got left behind. They found that transport decisions follow a predictable pattern. Hunters prioritize meat weight over bone weight. They prioritize high-calorie body parts like the thighs and upper back. They leave behind skulls, lower limbs, and vertebrae, which have low meat-to-bone ratios. Pabina's research confirmed what the FK Zinj bones had already suggested. Ancient human transport was strategic. It was not random. It was optimized. But here is where it gets more complicated. Butchery at the kill site solves one problem and creates another. When you cut up an animal in the open, you are working fast. You are exposed. Predators can see you. The smell of blood attracts every scavenger in the area. You need to work quickly, make decisions on the spot, and get out before something bigger shows up. This meant that ancient humans had to be expert butchers. They had to know exactly where to cut. They had to know which tendons to sever, which joints to separate, which bones to discard. A bad butcher wastes time. Time is the one thing you do not have at a kill site. In 2014, Dr. Manuel Dominguez Rodrigo at Complutense University of Madrid published a study of butchery efficiency in experimental settings. He showed that experienced butchers using stone tools can process a medium-sized antelope in under an hour. Inexperienced butchers take 3 times as long. The difference between a successful transport and a failed one could be measured in minutes. If you take too long, hyenas arrive. If hyenas arrive, you lose your kill. So ancient humans were not just hunters. They were master butchers who understood animal anatomy as well as any modern surgeon. They had to. Their survival depended on it. Let me talk about a different kind of evidence. The bones tell us what was transported, but they do not tell us exactly how. How did an ancient human physically carry 100 pounds of meat across miles of rough terrain? This is where the archaeological record gets harder to read. Organic materials rot. Carrying devices made of wood, leather, or plant fibers rarely survive for hundreds of thousands of years. But we can infer from what we do find. In 2012, researchers at Abri du Marais in France discovered a fragment of twisted plant fiber string at a Neanderthal site dating to roughly 52,000 years ago. This is the oldest direct evidence of string technology ever found. String is not just string. String is the basis of nets, bags, slings, and carrying devices. If Neanderthals could make string, they could make carrying bags. And in 2020, researchers at Hohlfels Cave in Germany found a 35,000-year-old tool carved from mammoth ivory, specifically designed for twisting plant fibers into rope, a dedicated rope-making machine from the Ice Age. This tells us that by 35,000 years ago, modern humans had the technology to make strong, reliable ropes. Ropes that could be used to tie meat bundles. Ropes that could be used to drag heavy loads. But the simplest carrying device may be even older. Look at your own body. You have shoulders, you have a back, you have 2 arms. The human body is itself a carrying device. In 1978, Glynn Isaac at UC Berkeley proposed a radical idea. He called it the home base hypothesis. Isaac argued that the shift from eating food where you find it to carrying food to a central location was one of the most important transitions in human evolution. It required planning, cooperation, and communication. It required individuals to delay gratification to carry food now so they could share it later. Isaac believed this behavior shaped the evolution of the human brain. Carrying food home is not instinctive. Chimpanzees do not carry food back to a central camp. They eat where they find it. The decision to transport food requires a mental leap. You have to imagine a future moment when you will eat this food with others. You have to weigh the cost of carrying against the benefit of sharing. You have to trust that when you arrive back at camp, the food will be shared fairly. This is why the schlep effect is not just a logistics problem. It is a social problem. It is a cognitive problem. It is a problem of trust, cooperation, and planning. Now think about the actual physical act of carrying. 100 pounds of meat does not have handles. It does not come in a neat package. It is slippery, bloody, heavy, and awkward. How did they do it? Anthropologists who study modern hunter-gatherers have documented several transport methods. The most common is the tumpline. A tumpline is a strap that goes across the forehead or chest and attaches to a load on your back. It transfers the weight from your arms to your spine, allowing you to carry much heavier loads over longer distances. Tumplines are used by indigenous peoples across the Americas, Africa, and Asia. They may be one of the oldest carrying technologies in human history. There is also the carrying net. The Hadza of Tanzania make nets from plant fibers that can hold up to 60 pounds of meat. They spread the net on the ground, pile the meat on top, gather the edges, and lift the bundle onto someone. The net distributes the weight evenly and keeps the meat contained. And there is the simple butcher wrap. You cut the meat into long strips, wrap it in the animal's own hide, and tie it with sinew. The hide acts as a natural carrying bag. It is waterproof, strong, and biodegradable, which means it does not survive in the archaeological record, but it definitely existed in prehistory. Let me throw something at you. A 1988 study by James O'Connell and Kristen Hawkes at the University of Utah looked at how the Hadza make transport decisions. The Hadza live in northern Tanzania and still practice traditional hunting and gathering. O'Connell and Hawkes followed Hadza hunters after kills and recorded what they did. The results were surprising. Hadza hunters do not carry whole animals. They do not even carry whole limbs. They cut the meat into small, manageable pieces at the kill site. They discard the heavy bones. They leave behind parts that would spoil before the meat could be eaten, and then they walk back to camp carrying bundles that weigh between 30 and 60 pounds. But here is the key finding. Hadza hunters prioritize transport efficiency over meat quantity. They would rather carry a small amount of meat quickly than a large amount slowly. They know that if they take too long, either predators will get the meat or the sun will spoil it. Speed matters more than volume. This preference for speed over volume has big implications for how we think about ancient hunting. The image of a group of men struggling to drag an entire antelope back to camp is romantic, but inaccurate. The reality was more like a group of people working efficiently at a kill site, cutting, wrapping, and walking, treating the whole operation like a well-practiced assembly line. But what about really big animals? What about mammoths? A woolly mammoth could weigh 12,000 pounds. That is 12,000 pounds of meat, bone, and hair. You cannot carry that. You cannot drag it. You cannot drag it. You cannot even lift a fraction of it. Archaeological sites associated with mammoth hunting contain evidence of a different strategy. The hunters did not try to move the mammoth. They moved themselves. They set up camp at the kill site. They processed the mammoth where it fell and lived there until the meat was consumed or preserved. At the site of Dolní Věstonice in the Czech Republic, archaeologists have found evidence of a settlement built entirely from mammoth bones. Dozens of mammoth skeletons arranged to form the walls of a dwelling. This was not a hunting camp. It was a mammoth processing village. The people lived inside the remains of the animals they had killed. This reverses our assumption about transport. Sometimes, instead of bringing the food to the camp, ancient humans brought the camp to the food. Now think about speed. Walking while carrying a heavy load is not the same as walking unloaded. Your center of gravity shifts. Your stride shortens. Your energy expenditure increases dramatically. A 2017 study by Dr. Herman Poncer at Duke University measured the energy cost of walking while carrying loads in modern Hadza and Western participants. Poncer found that carrying a load equal to 20% of your body weight increases your energy expenditure by about 30%. Carrying a load equal to 50% of your body weight more than doubles your energy expenditure. This means that ancient humans had to eat significantly more calories on days when they carried meat. The transport cost was built into the caloric budget of hunting itself. And then there is the question of distance. How far did ancient humans carry their meat? The Kubi Fora region in Kenya has provided some of the best evidence for transport distances. Geologists and archaeologists have been able to trace the origins of stone tools found at Kubi Fora back to their source outcrops. Some of these tools were made from stone found more than 10 kilometers away. If humans were carrying stones 10 kilometers, they were certainly carrying meat that far too. Dr. Thomas Plummer at Queen's College has argued that transport distances of 10 to 20 kilometers were probably routine for early hominids. This is not a short walk. This is a 2 to 4 hour hike while carrying a heavy load of meat. This is endurance transport. Let me reframe what we have been talking about. The inability to carry large prey is not a weakness. It is a design feature. Humans are not strong compared to other animals. A chimpanzee our size is 4 times stronger than we are. But humans are endurance champions. We can walk for hours. We can carry loads while walking. We sweat efficiently to cool our bodies. We can keep moving when other animals would overheat and stop. The Schlepp effect is not a sign that ancient humans were struggling against their physical limitations. It is a sign that they were working with their strengths. They did not try to drag 700 pounds of meat because they did not need to. They could make many trips. They could organize group efforts. They could process food at the kill site. They were solving the transport problem, not with muscle, but with intelligence and cooperation. Consider the role of butchery tools. A 1999 study by Dr. Kathy Schick and Dr. Nicholas Toth at Indiana University, Stone Age Institute, showed that the effectiveness of stone tool butchery improved dramatically over time. Earlier tools were simple flakes. Later tools became more specialized, including scrapers for cleaning hides and knives for precise cutting. Better tools meant faster butchery. Faster butchery meant safer kill sites. Safer kill sites meant more meat made it back to camp. The evolution of butchery tools is itself a record of transport optimization. Each improvement in cutting efficiency reduced the time spent at the kill site. Each reduction in time reduced the risk of losing the kill to predators. The tools became smaller, sharper, and more portable. Ancient humans were designing their tools for the transport problem as much as for the hunting problem. Now, let me talk about something you probably never considered: the division of labor in meat transport. Modern hunter-gatherer societies show a clear pattern. Men tend to do the hunting. Women tend to do the gathering. But when it comes to transporting meat from a kill, the pattern is more complex. In many societies, women and children participate in the transport of meat from large kills. The entire group may walk to the kill site, help with processing, and carry portions back to camp. This makes logistical sense. A large animal represents thousands of calories. It is worth the group's time to go get it. And having many carriers means the meat arrives faster, the work is shared, and no single person is overloaded. A 2012 study by Dr. Bridget Alex at Harvard University examined the energetics of cooperative food transport among modern foragers. She found that group transport is significantly more efficient than individual transport. When 4 people carry a total of 200 pounds of meat, each person carries 50 pounds. But they complete the trip faster because they can rotate loads, share the burden, and maintain a quicker pace. The time savings are substantial, and the risk is lower because more eyes are watching for predators. So ancient humans were not just strong, they were organized. The transport of heavy prey was a group project that required coordination, communication, and trust. Let me bring this back to you. The next time you carry groceries from your car to your kitchen, you are performing an act that has been central to human survival for nearly 2 million years. You are transporting food. You are schlepping. You are participating in a behavior that shaped the evolution of your brain, your body, and your society. The only difference is your groceries come in plastic bags. Your ancestors' groceries came with fur, hooves, and the constant threat of being eaten by something bigger than them. You carry heavy things because your ancestors learned how to carry heavier things. You organize group efforts because your ancestors learned that cooperation beat individual strength. You plan ahead because your ancestors learned that the meat is worthless if you cannot get it home. The schlep effect is not a limitation. It is the reason you are here. You are still carrying. Here is a detail that will change how you picture an ancient kill site. Blood attracts predators. Not just the smell of blood, but the sound. A 2016 study by Dr. Joseph F. Biddle at Vanderbilt University showed that hyenas can detect the scent of fresh blood from over a kilometer away in open terrain. And hyenas are not subtle. When they arrive in groups. A single hyena can consume 30 pounds of meat in one feeding. A clan of 20 hyenas can strip a zebra carcass clean in under 30 minutes. This means ancient humans had a very narrow window to process their kill. They had to work fast, work efficiently, and get out before the hyenas showed up. Every minute spent at the kill site increased the risk of losing everything. The pressure was not just physical, it was psychological. You are cutting meat while knowing that predators are already smelling it. You are wrapping bundles while knowing that a clan of hyenas is heading in your direction. You are making decisions about which parts to keep and which to abandon while the clock is ticking down on your survival. The transport of heavy prey was not a slow, methodical process. It was a race against time, and the winners were the ones who could butcher fastest, pack smartest, and walk away before the competition arrived.